Hello. Please give me a like if you hear me well. Super. Hello again. My name is Daria Lashkevich, and I'm robotical eagle. Okay, I'm cheating on you on human, but I can train machines to see like an eagle because I am computer vision engineer. Just a little bit about me. I have been working in Accenture Baltics from 2017, around 7 years, and I am reinforcement learning and computer vision expert. If you want to connect me, please scan QR code to my LinkedIn and some boring stuff that, yeah, I have some AWS certification, and when I was a test manager, I also got a STQB certificate, and of course, to prove you that I am human, I have a son. Very active son, and I am mom, and that's why I'm really value work-life balance. And now my colleague actually told me that they had a lot of questions about Accenture, what Accenture it is, and I'm going to tell you a little bit about my company. But I am working in data and AI domain, and what we know about data and AI. Currently, Accenture is working in Latvia and Lithuania. In Latvia, we have around 2,000 people, and in Lithuania, we have 200 people. And in data and AI domain in Latvia and in Lithuania, we have more than 200 people. The Accenture Baltic data and AI, one of the largest centers across whole Accenture in the world. And across the world, we have around 170,000 people, I think, if I am not mistaken. And we are working already more than 9 years, and we delivered more than 270 projects. But what we are actually doing, with which technique we are working, we have some different departments, and we have RPA, it's intelligent automation. We have a conversational AI, this magician who working with the chatbots. We also have industrial cloud and platforms. It's our DevOps and MLOps stuff. Machine learning and data science, it's my guild. I'm working there. And we have some recommendation system, computer vision. I will show you on next slide. Also, we have a very big data engineering guild who is working with big data and some augmented insight. We are working with all 3 clouds, and more than 80% of our people certified in different clouds. And a little more words about my guild. I am working in machine learning, of course, and we have a lot of innovation projects. It's OCR detection, some fraud detection. We are a little bit working with generative AI and LLL system, but it's not a client project yet. It's more than like a proof of concept. Me personally working in a computer vision team. We have 7 people here, and we already delivered 4 projects for clients, and all of them are working in production. And we also have 2 clients reinforcement learning projects. One of them is already in production, and one we are going to launch in production in January. And currently, we are also developing our MLOps stuff. If you are interested in any technique, please don't be hesitate to go to our Accenture stage and ask your questions. And now, let's back to our topic. I think you already attend some topics from my colleague, and you know that actually every image detection requires some labeling stuff. It means that a lot of people just sitting and manually labeling classes. It's a cat, it's a car, it's a dog, and sometimes it takes a lot of time. But what if we couldn't use pre-trained model? We couldn't use some generalist model that could detect cats and dogs. What if we should detect something special? For example, fuel pipes. In such case, we need to create your own labeling team and to collect data from scratch. And, for example, for one client, we had a problem with the last labeling team who was on outsource. we just have 8 seconds per image, but we created our own labeling team. And now, before our tool, they're spending 40 seconds per image, plus 32 seconds just to install everything, to create environments and something like that. And just imagine, if you have 1,000 use cases, and for every use cases, you should label 1,000 images. It's 1 million images, and it takes around 8,000 point, a little bit before 9,000 hours. It's forever, you know? And actually, what we did in the first stage, you know that Meta, as a Facebook, released some segment anything model, which you can use for any segmentation, and we just upgraded it to use a few short learning, when you can create very, very small data set, less than 100 or even 50 pictures with your current object, and train a model very fast, like this, and you can get a product where you can only make 2 or 1 click and get labeled pictures, really. I can show you a demo. It's our proof of concept, how we can prepare some labeling for wood defects. You can see that actually here we have a counter of clicks. Unfortunately, I don't have a laser. And if we just make several clicks, 2 or 1 on every defect, after that, in labeling tool, we can see that it will be segmented, will be labeling. And I hope you know that we can label by bounding boxes, like rectangles, and we also can label by polygons. It means that we can draw the whole contour of every object. And it takes really a lot of time. But for this tool, you can easily just label everything. Only one thing. If you need to label a picture or an object, whereas your object has a similar color with big background, yeah, it might be challenging. But if you can easily, with human eye, notice that you can actually differentiate this object from a background, for example, like this, we can easily notice that it's kind of defect. In such case, yeah, it should work. And I think now some magic happened. We can see how it's labeling. It's a labeling tool. Let's upload. Yeah, you see? We didn't do this drawing. And this labeling tool we are now using for all our use cases, for every client what we have. Now, let's talk about our client case. Just imagine, you are a hard worker in a car plant. You are producing cars. And you are staying near the car assembly, doing a job by hands every day, 10 hours. It's already end of business day, and you look tired, and you missed something. You didn't notice that you made a mistake. What happened? It means that maybe some other people also missed your mistake, and some person can get a not so safe car, but robot never made a mistake. And that's why we created some computer vision solutions which could detect how correct our car were created. Now it's a big project, and it's already scalable for 30 plants worldwide, in USA, in Europe, in China, in Mexico, and I think in South Africa we have one. But actually what had happened, in different stages of car assembly, we put cameras. It's a high quality image cameras for 4K. And after that, just business made some requirements. Okay, for example, for this one, you should detect that we have 4 plugs for every wheel. Only 4 special plugs, just detect it and calculate that there are 4. After that, they they build in a car and we collect data set, like OK and NOK images, but just thinking a little bit, for NOK images, what actually our plant should do? They should brake the car. And if you need 100 NOK, they should brake 100 cars. Can you imagine how expensive how much it costs? And for this one, sometimes we can generate synthetic data, but I will show it later. After that, we need to label images. Remember, seen by humans. But now, when we are using our labeling tool, it's take not so much time. And after that, we train it. It's in different neural network architecture. It should be detection model, classification model, segmentation model, depends on requirements. We deploy it to cloud. We are currently using Azure cloud. And after that, business just make aptitude test. They, again, broke some cars, just to prove that model are working. And actually, there are a lot of stages, but I just going to show you some use cases, how actually it really looks like. Unfortunately, I cannot show you much more pictures because it's a client project, but we can show only approved client pictures. For example, it's one of example. Please raise your hands if you know before this slide how actually airbag in car looks like. 1, 2, 3, 4. Oh, actually a lot of people. Yeah, but how we should install it? This is airbag, how it looks like before crash incident. And it's one of our legacy use case. Because just imagine that if some worker could install this airbag and rotated it. Or for example, it could install it incorrectly, completely incorrectly, but no one noticed. But our system just detects every airbag and put some OKs and NOKs in a system. And if computer vision just detects that it's NOKs, a real human just got a SMS. Okay, we have one NOK on assembly, but assembly never stop. Because if you stop assembly, 1 minute of stop assembly, it will cost 30,000 euros. It's always moving, and that's why one human should run and check, is it real on okay or not? And according to this one, for this project, we have requirements 99% accuracy. Not less, 99%. And you could do whatever you want, but 99%. And of course, if car assembly always moving, inference time should be less than 10 seconds. 10 seconds, it's never mind how much models you have. 10 seconds and 99%. We started this project from 2020. And if you buy a car from any German company from 2020, you can be sure you will be safe. Robot saved your life because we checked all our cars from 2020. And it's other use case. Actually, we have a joke regarding this use case. My teammates just named it that you try to detect a black cat in a black room in the midnight. Because basically you should detect some special sink, special plug, which also have the same color as the background, and you also should detect is it absent or present. For this use case, we are using two-stage model. Once we detect area of interest, you can see it here, like present in the bottom one, and in the above picture, you can see that it's absent. And after that, we classify it. Is it present or absent? If some cars with missed plugs will go to the market, our client just will have some reputation risks. We couldn't do like this. And what we actually do, just to create our data. Of course, we can break our cars, but first of all, we should anonymize our data because there are a lot of workers around. After that, you should clean our data. And after that, you should make some argumentation. What is argumentation is, I think you know, but in simple words, do you have all Instagram? Who have Instagram? Okay. Actually, argumentation, I would say that if you are crazy Instagrammer, you can just apply all filters which you have. And it's kind of argumentation, because it's randomly change your saturation, contrast, brightness. It's also could be rotated somehow randomly. It also could be blurring, and it also could be in grayscaling. And for our models, all this data will be completely different from each other. But sometimes we as a human cannot see such pictures. And of course, if we just need to find some black cat in a black plug and some black background, in such case, yeah, we can see some infrared. We can see these pictures like in black and white, but anyway, we still can detect something. But we are not detecting only what we can see. But for current client, we also can detect what we can hear. I need your help. Can you please create now a sound how car engine sounds? Please do it for me. Oh, it should be more constant. Oh, yeah, where you drive in a car. And now, please try to create some special sound if something's wrong in your engine. Please try. Nice, nice. Very nice. Okay, maybe sometimes it will be not so loud, and we couldn't notice it, but the model could. We just install microphones in all our cars during our first test drive, and they are recording engine sound, and after that we convert this sound to spectrograms. And for these spectrograms, we just apply computer vision classification techniques, and you see actually, even with human eyes, you can see the difference. In the buff, it's an okay. You can see peaks. It's like for such sounds, right? And here, it's a normal sound of your engine. I think everybody who even sometimes bought a car knows that it's the most expensive problem if you have something broken in your engine. For this check from 2020, I hope we can avoid it. But now, let's see actually how a normal engine sound. It's our proof of concept for the all automotive client, but we also can detect not only what we can see, but also what we can't notice if something. Just go back to plant. If you are working hard on a plant, near car assembly, and one of your engine starts vibrating. It's vibrating faster, 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 but you couldn't notice it because if it's vibrating under higher voltage, it's vibrating very, very fast, and you couldn't notice it. But the robot can. And if engine is vibrating under high voltage, it might cause any problems inside. But it's really hard to notice in some noisy areas, if you couldn't hear it, or if you have some smoke areas in plants, or if you have some special light conditions. Let's see how it looks like, but not in a plant, in our office. Here. It's like a normal vibration. We can live with it. A little bit more. And now increase. Looks like your neighbors above just doing some repairs, right? And it's the most dangerous. We can see, we can hear the sound, but we couldn't notice the vibration. What we actually did, remember regarding semantic segmentation, masking, yeah? And regarding our labeling tool, we can segment it. After that, we can mask difference, and after that, we just make our mask binary. And it's our amplitude. Based on this amplitude, we can easily make a conclusion how big voltage was and how it's dangerous for us or for this engine. For example, here. Okay, I think it doesn't work. Yeah, it's working. You see? 6 volts, actually it has small amplitude, and here, the most dangerous, how it looks like here. Here you can easily notice vibration, right? Just, you don't need some special equipment, only one camera, maybe even not so high quality, but with such camera, you can easily notice that vibration and save a lot of money for your client and maybe save your life if something could be explored, something like that. Yeah, but what if we don't want to create broken cars? What if it's too expensive for our client? Can we just go to generative AI, to DALL-E or to Stable Diffusion, and just asked him, okay, could you please create me a car with absent light? Or could you please create me a car of some, I don't know, Mercedes, for example, with a scratch on a door? What was the result? It could, right? But it maybe will be like more than like a cartoon. By the way, who already tried Accenture Stable Diffusion generator in Accenture 10? Okay, you should try, because in such case you can see how cartoon is it. Unfortunately, I don't have picture like this, but if we don't want to break our car, we ask our data team just to create synthetic data for us. But unfortunately, generative AI, for example, Stable Diffusion or DALL-E, it's like more generalist model. And it's working fine if you need some scratch on doors or if you need some absent wheels. But if you ask some generative AI to create some broken fuel pipes or some broken brakes or airbag rotated, it will be failed. Unfortunately, in such case, we should retrain our model from scratch. And actually, we try to do it, but unsuccessful just because I don't have pictures now. Maybe in the next conference, I can show these pictures to you. But okay, I think you're already tired from cars, right? Let's talk about another project. Now, just imagine that you're a photographer in a jungle. And you just want to make some shots of different animals, dangerous animals, tigers, leopards. But you suffer from mosquitoes, you can catch some Ebola, you can catch some other disease, and high risky, and of course some tigers could be very dangerous and can hurt you. And that's why we are trying to create solution just to make a photo for follow population, for detect species with some special tiny cameras. And it's a real project which we delivered to Gabon. It's a special model which could detect some species in a real outside life, even if it's hidden under leaf, in any weather, when it's drizzling, when it's raining, doesn't matter. And this device couldn't suffer from mosquitoes. This device couldn't suffer from diseases. It could just follow their job. And actually, we get challenging because we just achieve 85% of accuracy. How this device looks like? It's like this, masking somehow, and it's called the camera traps. We can just go to Gabon once, just install this special device, and after that, this captures images, upload them to cloud, and after that, detect some species. What is it, tiger, or is it deer, or is it monkey, something like that. But for some times, we can even create so light detection model that it could be operating inside this device. We don't need internet. We don't need cloud. We just can take a picture, detect who is it, and only after that, just send not a picture, not upload a picture, but send a prediction, like a word, who is it and where. But do you know actually what challenge we have with data with this use case? First of all, for this project, it was really hard to create data set. And some client, of course, provided data set for us, but the data set was completely imbalanced. And what we did, actually, we just combined some classes. For example, we have some different classes of monkeys, like chimpanzee or epi, and we just combine it under one class, monkey. And of course, we clean it because it could be very similar pictures. No one just follows that tiger, for example, standing in one place. And of course, some complex background. Of course, some animals could be hiding under the leaf. It should be raining. Well, I couldn't say that it might be snow, but who knows? And sometimes we can see only part of animals. For example, tails, only half of animals. And when we clean everything, we got such kind of data set. You see, it's kind of imbalance. I think it's 20,000 pictures for deer, and pangolin have only 21. But just let's check your attention. Did you notice something strange in this data set? No? Yeah, because actually I already told that we combine, for example, chimpanzee and ape under one class, but we have here class ape. And how the most challenging pictures in our data set could look like this. Okay, here it's a pangolin. You can easily notice it, but who is here? Who? Okay, it might be monkey. Who is here? It's a sun. Who is here? I hope so. And also, for example, for this one, it's also pangolin. But you can see that some animals, it's so big that they couldn't detect correctly in some pictures just because they're too big or they just come so close to our device, and we should detect everything. And also, for example, what we can do with such images. It's a black square, you know. For this, the data set, we also just accept some normalization. Normalization, it's you can change your intensity of pixels. I think computer engineers should be good photographers because we just accept all the same techniques which actually good photographers accept. And here you can see that it's a red deer, right? But now I can show you our confusion matrix, what we have. Basically, even with all these challenges, we still have a normal confusion matrix, not so much pseudo-NO case. But now, if you just check how much classes it is, did you notice something strange? It's in a jungle in Gabon. Something strange. Anyone? Okay. We have a human here. 100 human, I think it's here. We have a human here. Just because we checked our data set for all open source data sets which we could find, and it works. It's just a simple detection model which could be lighted inside this device, and it was trained in TensorFlow Lite, just because it could operate very fast and very quick, and it's very light. And even if we have some pseudo-NO case, but let me show you one example how our pseudo-NO case looks like. Here. Any guesses who it is? Or in the second picture, or in the second picture? Unfortunately, even using all our techniques, we couldn't say who it is. But we achieved 86% accuracy for this model, and it's still working in production. And the one example which actually we are proud of, we can easily detect this bird. It should be like this, should look like this, but it's completely hiding. It's also from open source data set. And I think now it's working well. Okay, regarding use cases, I think this is it, and let's make some recap. UCV model always depends on your data. And I would say that it depends on data 98%. Of course, you can try to use some not high quality data and try to use some open source, but I think we have another speaker from different company who also has image classification, and he also told that if you are using open source and not high quality data, you can achieve only 60% of accuracy. Yeah, and of course, make some argumentations, be a crazy Instagrammers, also make some flips and blurriness. Just play all Instagram fields what you have. And also you should try camera angles. If you can affect how you can create your data set, you can affect as much as you can. If you just create some special data set, please try any camera angles. Please try any light conditions, whichever you have. Like with the night light, with the artificial light, with the sunlight, or if you're just doing it outside, please pay attention to all weather conditions. Too rainy, too drizzling, too snow. Because you know that it could be snow, but model didn't. You should train it. And one more time, better image quality, it's equal better model accuracy. If you really want to create a solution which could follow 99% of accuracy or even 100% accuracy, you should create your in-house dataset. I think that's it which I have. Thank you. And we have time for questions.
Thank you, Daria. Folks, do we have any questions? Yes.
Hello, thank you for your presentation. Have you evaluated if these devices would upload pictures to cloud, and in cloud you will detect what kind of animal is? Would the accuracy better or the same?
Accuracy will be the same. We tried it, but it's a speed problem. Because to upload picture to cloud, it's much slow if you just do it on place.